They're much more fun. I would love to see Bax's reaction.
All right.
Bax would be like, oh my god.
All right. So yesterday, what were we talking about? Special trig limits, right? There's 4 of them. This is more special trig limits.
So we're silent.
So yeah, they were, the limit as x goes to 0 of sine x over x equals 1. The limit as x goes to 0 of x over sine x equals 1. The limit as x goes to 0 of cosine x minus 1 over x equals 0. And the limit as x goes to 0 of 1 minus cosine x over x equals 0. So we got these limits, remember, just by examining the graph, okay, and figuring out where the graphs are headed towards. Because all of these were examples of functions that if you just try and plug in the number, you get 0 over 0, which alerts your brain to the fact that there has to be a hole in the function at that point, at 0. So you just really, your goal is to figure out what the y coordinate of the hole is at that point. Any questions on that? That's what we did yesterday. Okay, so sometimes they're going to give you trig limits that are kind of like these, but not exactly like these. And you have to sort of manipulate them algebraically to get them to look like these. Okay, so here's an example. The first thing to understand is, although I said the limit as x goes to 0 of sine x over x equals 1, it doesn't have to be x. Like, it can be anything, which sounds obvious. It could be the limit as anything at all. Anything could be in this. Goes to 0 of sine of anything at all over anything at all. As long as that stuff's the same, then the answer is 1. Now, this might seem obvious, and like, why do I do that? I just replaced x with box, which seems like stupid. But here's what I mean by that. Like, you could have something like this. You could have the limit as x goes to 0 of sine 3x over 3x, and it's still 1, even though this isn't a 3x. And the reason why is because if x is going to 0, then definitely 3x is also going to 0. Does that make sense? This could have been a 3x and nothing would change here, right? So this is sort of what I mean by putting boxes around things like this, okay? Or, I mean, by the same token, in number 2 up here, I could have taken the limit as x goes to 0 of 7x over sine 7x, and the answer would still be 1 for the same reason, because if x is going to 0, then 7x is also certainly going to 0, so that statement is true as well. So what if you have something where these don't exactly match up? Like, what if it's something like the limit as x goes to 0, what if it was like sine 5x over x, or something like that? And now it's a little bit of a different situation. If this denominator was a 5x, the answer would definitely be 1, right? So what I'm going to say is, let's just make it be 5x. The way we can make it be 5x is just by multiplying by 5. But whatever we do on the bottom, we have to do the same thing on the top. And now if you think about it, we really have the same thing. We have 5x on the bottom, and we have sine 5x on top. So this limit is 1. That limit is 1. So really, the answer here is 1 times 5. The answer is 5. So basically what I just did, I wrote 1 times 5, the answer is 5. So basically what I just did is I applied one of the rules of limits, which says if I have two functions multiplied together, f times g, and I'm taking the limit as x goes to 0, then that's really just the limit as x goes to 0 of f times the limit as x goes to 0 of g. I really have two functions multiplied together. It's sine 5x over 5x times 5. So the limit's just going to be 1 times 5. Does that make sense? Now, another way of thinking about this, no, don't think of it that way. Okay, yeah, let's think about that way. So another way of thinking about this is if you're taking the limit as x goes to 0 and you have sine of something and then the exact same thing either in the bottom or on the top, you know, right? If it's the opposite way around, then they essentially like cancel. They're not equal. I don't want you to think that sine 5x and 5x are equal, but their limit is 1. So it's almost like they cancel, like they're equal. You know what I mean? It's almost like you're just simplifying fractions. You can think of it that way. So what if I had something like the limit as x goes to 0 of something like 3x over sine x? I mean, you can just think of this as being 1. So the answer is just 3. And an easier example than the one we just did, actually. That answer is just 3. Is everybody okay so far? So sometimes the answers, the problems can get a little bit more sophisticated. Like, what if you have something like the limit as x goes to 0? What if it was like sine squared x over 2x squared? Something like that. Well, this can be rewritten. This can be rewritten as limit as x goes to 0 of sine x times sine x. That's what sine squared x really is. And then 2x times 2x. 2x squared really is, right? And then these cancel, kind of, because their limit is 1. And these cancel, because their limit is 1. So the answer here would be what? 1/4. That make sense? Let's do some other weird examples. How about this? What if I have something like the limit as x goes to 0 of 3x plus sine x over x? Any ideas on how to handle this?
You can't leave it with variable.
What do you mean?
Or like a letter. Probably the word. So
A
yeah,
letter.
Variables for,
Okay. So
you're talking about x, yeah?
Yeah, it can't be 3x because sine x over x would be 1, right?
Right, so then it would be
Plus
3x.
3x. But it can't have a letter, right?
Right.
So confused. What are you saying the answer is?
3x.
Well, wouldn't it be 3x plus 1? With what we were saying right now?
Yeah.
Yeah.
I think you might be on the right track. What I'm thinking is let's split it up into two fractions. Like you could split this up to be the limit as x goes to 0. This is really like 3x over x plus sine x over x. That's what I'm thinking. And then use the laws of limits to say this is really the limit as x goes to 0 of 3x over x plus the limit as x goes to 0 of sine x over x. All right? This one's 1. That's 1.
So what is 3 plus 1?
What is this one?
3.
Yeah, it's 3. You can cancel a common factor, and the answer is 3.
Oh, so we can do it, we just can't do simple math. Yeah.
So I think you were on the right track, right?
Yeah, kind of.
Yeah, pretty much.
Yeah.
You just didn't divide this by x.
Yeah.
Right, yeah.
Yeah, so the answer here would be 4. So that's kind of easy, right?
Yeah.
How about this one? What about this? Limit if x goes to 0 of sine x over 2 over 3x. Okay, so since there's a sine x over 2 on top, what do I really hope there is on the bottom to cancel with the sine x over 2? it would be really convenient if there was an x over 2 on the bottom, because then they would just cancel each other out. But there's already an x there, so I don't need to multiply by x over 2. I really just need to multiply by 1/2. But whatever I do on top, I got to do on the bottom. I have to do the same thing on the top. So now I have sine x over 2, which cancels with x over 2. Right?
Okay.
That blue stuff has a limit of 1. So the answer here is 1/2 divided by 3. 1/6 is the answer.
So why not just like multiply by 2?
By 2?
Yeah, like couldn't you just do like sine x over 2 times 2 and then the bottom by 2? And then you would just have like the same answer, right?
You could, yeah. That's confusing her to me.
Oh, okay.
It's not to you?
No, that makes way more sense.
Because then I'm thinking, okay, where does the x over 2? You'd have to then put it together. All right, so what she's saying is you have the limit as x goes to 0. So maybe this isn't more confusing for everyone, just for me. It's possible. So what you're saying is just multiply by 2.
Yeah.
But then what you have to do mentally is you have to realize that this is really x over 2.
Well,
which cancels with this.
well, no, because when you multiply by 2, then it's like
It's a
sine x,
over
and then it's then
6x.
yeah over.
No, that's not true. No.
Well, that's what it, that's what
Right
it
now,
was like.
this can't just be multiplied in there. That's definitely not. That doesn't work algebraically. Now you're thinking, well, it doesn't matter. It's kind of doing that, but no, don't think that that does that. That definitely doesn't. Like if you have sine of A times B, this is not the same thing as sine of AB. That doesn't work ever. Right? Like if I take on my calculator, if I take the sine of 5 degrees and I multiply that times 2, that's not the same thing as taking the sine of 10 degrees. It's definitely not the same. It doesn't work ever. Okay? So that's definitely not what's happening algebraically here. I definitely wouldn't do that. I feel like sometimes that's going to fail. Okay? So this is a little bit better, right?
Okay, yeah. Coincidentally happened to work out for me.
Yeah, I mean, it's like 2 mistakes that end up giving you the right answer. It doesn't, that's not good.
I'm good at that.
All right, let's do another one. How about this? What about this? All right, how about this? How about the limit as x goes to infinity of 1 over x sine 1 over x.
Okay. So then do the thing we did up there, but with the 1 over x and in the opposite direction. That help? What?
Do what?
Like, could we do what we did up there, but in the opposite direction?
Well, the problem is this isn't the limit as x goes to 0.
That's true.
These rules only work if x goes to 0.
And I don't know.
But do you agree that this could be written as the limit as x goes to infinity of 1 over x over sine 1 over x? Do you agree that that's the same as that?
Yeah.
That's definitely the same,
Okay.
right?
Yeah.
Now, as x goes to infinity, isn't it true that 1 over x is actually going to 0? Right? If x is going to infinity, then 1 over x is certainly going to 0, right?
Right,
Because you get 1/10, 1/100, 1/1000, 1/1,000,000. It's getting closer to 0, right?
Right. So
really, what we have is the limit as something goes to 0 of something over sine something. The answer is actually 1. This is like a weird version of the same rule. Do you agree?
Yeah. Strange.
How about this? What if I had the limit as x goes to 0 of x cosecant x? What about that? Like, we don't have a rule up here that says anything about cosecant.
Yeah, what does that look like again?
What did you say? It is 1 over sine, so let's write it that way. This is really the limit as x goes to 0 of x times 1 over sine x, but that's 1. X over sine x.
Like knowing what cosecant was would be helpful in that situation.
What about the limit as x goes to 0 of tangent x over x?
Does it equal 1?
Oh, is it?
Even 1 is 0. Whoa, where are we going? Tangent is.
What's that?
Sine over cosine.
Sine over cosine. So this is like
Sure
the
is.
limit as x goes to 0 of sine x over cosine x over x, which I could write as the limit as x goes to 0.
Brave.
One thing at a time here.
That's this. But then this, that's 1. So what's the answer?
1 over cosine x. 1.
It's 1. Because cosine of 0 is 1. Cosine 0 is 1. Right? Cosine of 0 is 1.
There's so many rules.
How about the limit as x goes to 0 of sine 5x over sine 2x? And don't say, well, you just cancel the sines and cancel the x's. That doesn't work. Sine is not a product. Like sine is not a factor that can be canceled like a common factor. It would be like canceling a square or something. That's not a factor that can be canceled. Well, there's a sine 5x on top. What would it be really nice if there was something on the bottom? 5x. So let's make a 5x. So then this goes with that. Now, there's a sine 2x on the bottom. What would be really cool if there was on the top?
2x.
2x, but there's already an x.
Whoa.
So then sine 2x goes with 2x. So the answer is 5 halves.
Wait, so it does. Oh, that's so.
No, but it doesn't work when you're thinking it. What's that?
Give us one that won't be the same numbers.
Yeah, no, my backwards logic is.
Give
working
you an
really
example
well right
just
now.
like this that doesn't work just like this?
Yeah, because
There's
it keeps working, man.
Shiloh. I'm trying to go. Limit as x goes to 0 of cosine 3x over cotangent 5x.
Just a fancy letters up there. Cotangent.
What?
One number. So do I have any guesses?
1.
Who thinks the answer is 1?
I don't know.
Who thinks the answer is 3/5?
It's 5/3.
Who thinks the answer is 5/3?
It's not one.
1. 0. 3
17.
You go by the same rules as you apply
It's 5
above.
I didn't apply any rules up there. I didn't do any rules. That's the thing. That's what I'm saying. Like,
I applied nothing.
I didn't do a rule. I did the only rule I did is sine 5x over 5x is 1. So let's do the same thing we did before.
Okay.
Okay.
Let's have a tangent again.
What we did before is we changed we made signs,
Cosine.
right? We turned things into signs.
Oh.
That's what we did, right? So this is really cosine 3x over cosine 5x over sine 5x, right? Cotangent is cosine over sine, correct?
Okey-doke.
Okay, so that means this can be written as cosine 3x times sine 5x over cosine 5x. Okay, so far?
Yeah.
Yeah.
Okay, so now let's do what we did before, what I did before. If there's a sine 5x on top, it would be cool if there was a sine 5x, or if there was a 5x on the bottom, right?
Already have a five.
No, there's a cosine 5x.
Oh, that's
That doesn't
okay.
cancel. So then, this and this cancel each other out, correct?
Yeah.
They sure do.
Okay. So then what?
Another one. It cancels out too.
Another one.
And you do three
Yeah.
of five X. Right?
No, the cosine, there's no rule there that says that works with cosine.
Oh, I thought there was.
Oh, that's something.
Dang it.
So you just gotta change everything to decide.
You can't change cosine into sine.
I'm stopping you. They just like convert it to five.
Oh, yeah, wait.
Hey. So here's where we are. The limit as x goes to 0
Yes.
of cosine 3x
Yes.
over cosine 5x. That's 5. That's where we are.
Make it 0 so that it's.
Three doesn't have five.
Wait, can we do the thing from, well, no, because it's not from.
Cosine 0 is 1.
I don't know.
You said wait.
I'm sorry, no, I'm saying it to myself.
Yeah.
That whole cosine thing about where it's gonna equal 3, that's, and then it's, oh, it's X.
It doesn't equal 3. That's not true.
Why not? Cosine 3. Doesn't have
Wait,
the
backwards one.
What's the first thing you're always supposed to try when you do limits?
factor.
No. No?
Graph.
No? What's the first thing you're always supposed to try when you do limits? No?
I don't know. Big brain.
How do you know there's a hole to begin with then?
If it's 0 over 0.
How do you know it's 0 over 0? Because you plug the number in, right? That's the first thing you should try and do is plug the number in. You can plug the number in here. You get cosine of 0, which is 1, over cosine of 0, which is 1, times 0. The answer is 0.
Oh, I said
Did I say that? Like, kind of, I was like, make it 0 so that it's 1. I swear I said that.
Okay.
It just came out.
Good for you.
So are we good?
Sure.
All right, good luck. It's an IXL assignment. So it's an IXL assignment, and it's just called evaluate limits using trigonometry.
I'm crying.
Personally, I think it's one of these problem.
I swear I said that. I said make it 0 so it's 1. I said
If you see cosine, you should just avoid.
Just
No,
run.
if you see cosine, make it 0. 0.
So to get to the assignment, remember